This video we will talk about for all the template header file we implement so far. Did you remember we have our value we're using the type V and the key type name key for the associative array or hash table. For the V and the value, we start using that in the dynamic array and static array. So let's talk about further when we're using this type name. If you remember, when we're using the type name in the template library, that means this type name, no matter V or K, they can replace with any data type. But so far, we only have the string by default. That's the string object for the key or for the value. But sometimes you need to think about when we have an array or a stack or a queue. If I want, I can have a student queue. I can have a student stack. I can have a student array. So that's why here, when we have those K or V, if they are using some user-defined object, what kind of requirements they need to meet? So we do have those requirements we talked about in the previous module reading, but I don't have time to discuss more with you. So now here I want to give you some summary. The first thing, no matter when we talk about the V or K as the value or the key in the dynamic array stack queue or the associative array hash table we just introduced in the past week, they has to be either no constructor or they has default constructor. Actually, on the other hand, we mean they have to have default constructor. Why? Did you remember all the time you try to initialize the V like this? If we want to have a default value, you need to initialize K like this. So when you're using these two syntax, that means you call the default constructor for V or K. So you either has to have those user-defined object has default constructor, or you don't have any constructor, right? Because any object user-defined, if they don't have any constructor, compiler will generate the default constructor. So the default constructor, we talk about that many times. That means the constructor function without any argument. So that's the requirement for any user-defined V or K. If we want to use for the template library, you need to make sure they have default constructor. So that's for the value for V and for K. But additional for the key we're using for the associative array and the hash table, we have another requirement. That means those key, if we want to use in the associative array, the key need to support, those key objects need to support the equal comparison. That means those user-defined K, if we want to use for the key in the associative array or a hash table, they have to implement the overloaded operator equal operator function. Why? Did you remember all the time when you implement associative array or in the hash table, all the time we have the user pass the key, we need to check if the key from the host object are they equal to the key, right? So that's why if that's the user-defined key type, they need to support the overloaded operator equal function. So on the other hand, for example, if my key is the student, how can I compare two students that are equal? Right, so that's why in your student class, you need to implement this overloaded operator equal member function. So that's how we can compare. So actually this one is we should talk about more in the past couple weeks, but we don't have a chance to talk about that. So now after we know the key and the value in the passing in the previous week, the template library we implement. So how about this week? When we talk about the value V in the priority queue, what requirement we need to meet? Right, same as key. They still need to have the default constructor. And the second thing, they need to support the less than comparison. So that means they need to have the operator less than comparison function. Okay, why? The reason is, did you remember here? So we just using this one for the push function. So the push function actually we say, right, if the parent index holding the value is smaller than the child index value, so then we need to swap, right? Right. So here actually we're using the last than. So that's in the push function. So we're using this last than to compare two values, which one is smaller, which one is greater. Then continue in the pop operation. So then a lot of time you see we need to compare that the parent value compared to the left children value, which one is bigger, which one is small. Right, of course here if you want, you can change to the greater than, but you need to switch these two operand. However, one thing is, we told you in the lab exercise 12, we told you please using only the last than. Of course, you can use greater than, but you just choose one. If you try to mix up greater than and the less than in your header file, that means here in your value, the value object in the priority queue, then you need to make sure they have all the overloaded operator comparison function to include. So that's why to easy our implementation. So that's why, remember in our priority queue header file, I told you all the time if you want to compare the value, please only using the less than comparison. So easier, you can just swap the operand. So we can always use only the less than. So since in our header file, we only use the less than comparison. So that's why any user-defined value, user-defined object, you want to replace the value, you just need to make sure you have your operator less than function defined. So for example, we have a struct we call time. The struct time has hour and the minutes. So can I compare the struct time? Yeah, of course you can, but you need to write that operator function. So here we just say, for example, because in our priority queue, we do the default is low to high. So that's why here, and also we implement using the last than operator. So that's why here the struct time, you have the operator function. So then you have the return type is bool. So this one actually they have two parameters. They have time A and the time B. So when we have the operator function, if you don't write as a member function, this one actually they write as the standalone function. So that's why here they have two time object. The first one we will consider they are on the left hand side for the operator less than. So then the B here, the second parameter we consider they are on the right hand side for the operator less than function. So what you need to do is you just compare, right? So you just need to convert your how to compare a time. Of course, we need to convert that or become minutes. So then you just return the value. Okay, so that's because we do the high to low operation. But one thing is, if you want to continue to use the priority queue we implement, the header file we implement, we're using the order is low to high, high to low, right? But now I want to use our priority queue, but I want to maintain a low to high priority. On the other hand, that means the lowest value I will pop first. Can I still using our priority queue library? You can. Just one thing is, when you want to using the low to high for our priority queue, you need to simply reverse the logic for your less than operator. So we still need the less than operator function. But you see here, instead of we do the A compared with B, actually we do the B compared to A. Actually, the B still is on the right-hand side for your operator. But now actually we need to reverse the logic. So that's why we just swap their value. So that's why your high to low will change to low to high. So that's the object in the template library function you need to be careful about.